Hello viewers, hello Ty. This is another video, FRQ Set to number 6. The time is 2:19 p.m. Okay, so I gotta do that. Gotta do it quickly. Hopefully I remember how to do this problem. Okay. So what we have is a sphere with a mass of 5 kilograms and radius of 10 centimeters or 0.1 meters. It is wrapped around with a string, which is attached to a pulley. The pulley has an eye of 3 times 10 to the negative 3 kilograms per meter squared, or 0.003 kilograms per meter squared, and has a radius of 5 centimeters or 0.05 meters. Lastly, there is a mass of 0.5 kilograms. Yes, okay. Part A asks, what is the speed of the object when it has fallen 80 centimeters after being released from rest? So, based on that, we know VI equals 0. We're supposed to find VF, and we know change in position is 80 centimeters or 0.8 meters. So, the first thing we do is we can find the acceleration of the block by finding the torque of the pulley. So, net torque equals moment of inertia times angular acceleration. Net torque equals net force times moment of arm. As you can see, your I is 0.003. And you can replace alpha, I think that's what it's called, right? It's something, angular acceleration, with A over R. Okay, so next we can divide R on both sides. So we can get delta F equals 0.003 A over R squared. Okay. There are two forces, TH and TV, standing for tension horizontal and tension vertical. The block is moving this way, and therefore TV is greater than TH. And those are the two forces touching the pulleys. Like that. Whoa! Okay, back to this. TV minus TH equals 0.003. A over R is, as we saw here, 0.05 meters, 0.05 squared. Alright, next what we can do is we have to find what TV is and find what TH is. Okay, so the TV is also touching this block, so we can set up a system for this block. There are two forces, FG and TV, and since the block is moving downwards, FG is greater than TV. So we have here, that's F equals MA, okay? FG minus TV equals MA, FG equals MG minus TV equals MA. Alright, next we isolate for TV. TV equals MG minus MA, and M is 0.5. TV equals 0.5G minus M. M is 0.5A. Okay, make it look better. 0.5A. And in the end, we get TV equals 4.9 minus 0.5A. Now, for TH. TH is touching this sphere, which is spinning around as this string is getting pulled. Therefore, there's another torque. So we can set up another torque equation. Torque equals I alpha. Okay. Torque equals F plus moment of arm equals, since this is a spherical shell, it means it is a hollow sphere, which gives it a moment of inertia of 2/3 mr squared. Once again, substitute alpha for A over R. Here we can cross out R squared and R, and we can cross out this R and that R. So we're left with delta F equals 2/3 ma. And the only F force touching this sphere is TH. M is 5. And we end up with TH equals 5/3A. So now what we can do is substitute both TV and TH onto this equation, which I would do. So we have TV minus TH equals 0.003A over 0.05 squared. So as we saw, TV equals 4.9 minus 0.5A. Okay. And TH was 5/3A. Okay. Equals, this can be simplified down to 1.2A. Okay. So next we move these two to the other side. 4.9 equals 0.5A plus 5/3A plus 1.2A. And we can combine like terms to get 5.03A, which means A equals 0.97 meters per second squared. Okay, so that's not the entire part A. We have to find the final speed after it goes down 0.8 meters. And what has A, V, I, Vf, and delta Y is common form. So common form is Vf squared minus Vi squared equals 2A delta Y. So we're trying to find Vf, so we isolate for Vf. Vf equals 2A delta Y plus Vi squared. Vi is 0, so we can cross that out. So Vf squared equals 2, A is 0.97, and delta Y is 0.8. So Vf squared will equal 1.552, and take the square root of that to get Vf equals 1.25 meters per second. Ta-da! That was a really bad box. Okay, part B. Part B is determine the time it takes for a block to descend 80 centimeters. Okay, so we already have displacement and we have acceleration, so we can use position function to find time. Delta Y equals Vi t plus 1/2 A t squared. Delta Y is 0.8. Something moved, I don't know what. Vi, as we said before, is 0, so we can cross that out. 1/2 0.97 t squared. Okay, so 0.8 equals 0.97 divided by 2 is 0.485 t squared. Move that to the other side. T squared equals 1.65, which means t equals 1.29 seconds. Okay, part C. Part C is determine the sphere shell's rotational kinetic energy after 80 centimeters. So, because it is on the same chord, the sphere and the block, it means the sphere will have the same Vf as the block, I guess, or the same acceleration and therefore the same Vf. But this Vf is not linear, it's rotational. So, okay, we have Ke rotational of the shell equals, so Ke rotational, the equation is 1/2 I omega squared. Okay. So I of the sphere, hollow sphere, is 2/3 mr squared. And we can substitute omega for V over R squared. So this will give us 1/3. M is 5. R, okay, 5. R squared, V squared over R squared. So as you can see here, we can cancel out these R's. So we get 1/3 times 5. And V, as we saw right here, is 1.25. And once we combine those, we will get Ke rot shell equals 2.6 joules. Okay. Alright, I'm out of room, so we'll move on to part D, right here. Part D says, what fraction of the total energy has been transferred to the pulley? So we know total energy consists of 3 energies since 3 things are moving. So Ke total equals Ke block plus Ke of the shell plus Ke of the pulley. So first thing you have to do is find the Ke of the block and Ke of the pulley, since we don't have that yet. So Ke total equals Ke block is linear, so 1/2 mv squared plus, we already have Ke of the shell, which is 2.6, plus Ke pulley is rotational because it's spinning in a circle, so 1/2 I omega squared. Okay, Ke total equals 1/2. Ke at the block is 0.5, V is 1.25 squared plus 2.6 plus 1/2. I of the pulley is 0.003. Omega squared can be converted to V squared over R squared as we did in part C. Okay, Ke total equals, this will end up as 0.391 plus 2.6 plus 1/2 0.003. V squared is 1.25, or V is 1.25, and then you square it, and R of the pulley is 0.05 and squared. So Ke total equals 0.391 plus 2.6 plus 0.938. Since we also need to find the Ke of the pulley, we'll just say, add as a note, Ke pulley equals 0.938. We'll need that later on in the problem. And then Ke total, you add them all up, and you get 3.929J. So the problem says, what fraction of the total energy has been transferred to the pulley? So we take the pulley. So Ke pulley equals 0.938. And to get a fraction of the Ke total, you divide by the Ke total. Which is 3.929 of Ke total. So Ke pulley equals this fraction of the Ke total. And if you simplify it, you will get 0.238 of Ke total. And since it's asking for a fraction, you have to put 238 or 1,000. Multiply the top and bottom by 1,000, by the way, of Ke total. And you can simplify that into 119 over 500 of Ke total. Alright, that's enough. Or that's it, actually. Yeah. Alright, let's find the time. The time now is 2:33. This took a while because I can't really find words to say, but other than that, that's it. See you next time.